All right. We're going to get started. So it's only 1 minute after we're supposed to start, and it looks like we have a full room. Congratulations, you made it back after lunch, and you made it to the right room. We are going to be talking about list comprehensions, generator expressions, and using them to loop over and process stuff, which is another word for data. So the way that I teach, I teach for a living. I do on-site training at companies. I also teach on the internet for fun, sometimes also for a living. I don't use slides when I teach. I don't use slides when I teach. Because of that, you don't get any form of speaker notes. Instead of speaker notes, what you will get is a class website. So I will be typing code. You will eventually be typing code here. I don't expect you to be typing the same code I'm typing here. You'll be watching me typing code during some periods of time, and then I will push it to you. You'll be working through exercises, and then I'll be wandering around the room along with the TAs. So that website, I actually am not entirely sure whether that's the right domain there. I think it is. Someone want to give me a thumbs up? Excellent. It works. So that is the class website. My notes are on there. My notes that we're loosely going to go by. We will occasionally flip around which section we're doing when. The important thing on that website for you, though, today are not my notes, because you're not going to be reading my notes as I'm speaking. You're going to be listening to me and participating here and answering my questions as I ask you things. The important thing for you on that website is the exercises. There are exercises on that website, and there is a zip file that we will be downloading before we go through those exercises. So on the home page of the website, at the very bottom, it says exercise test files. If you click on exercise test files on the website, you will download the zip file there. If you have any trouble getting the zip file during the first exercise section here, we will pass around a USB stick that has that zip file on it. Preferably download it from the website if your browser doesn't block you or you have any firewall issues there. Okay, so the way that I teach is I will be writing code, and then I will be asking you questions. This is an interactive tutorial, so I expect you to come with laptops and with your minds ready to answer questions, or at least to give guesses to things as we're going through stuff together. I ask you during the exercise section, that's when I am not up here talking and asking you questions. That's when I'm going to say, all right, now it's your turn. You're going to go work through exercises. That you put up red and green stickies. So I will say this again during the exercise section. When you have a question and I'm up here, I'm talking to you, I'm asking you stuff, raise your hand, shout something out, get my attention in some way, look confused, make something, do something that allows me to know that you want to say something. Maybe you have a question or want to make a comment. During the exercise section, I'd like you to, instead of raising your hand, put up a red sticky. You're allowed to raise your hand. I'd like you to put up a red sticky, though. What is it? Why do I use stickies? Does anyone want to guess why I use stickies instead of raising your hand? Less disruptive, maybe? You can use both hands, yes. It is difficult to type when you have a hand in the air, because I'm not a one-handed typer. I'm not a good one, at least. I expect most of you aren't. So sticky on the top of your laptop to indicate you have a question. You can keep on typing if there's something that you maybe want to type during that time. So this is to passively indicate you'd love someone to come over and ask you for help. I have TAs in the back of the room. They are back there with their hands. They're waving. You can't see them because you're all looking at me, which is wonderful, but they're back there. I've got 5 TAs. So during the exercise section, there are more than enough people to help you. If you have a question about anything, it doesn't matter if it seems related, feel free to put up a red sticky. You're not being rude by taking someone's time. That is what they signed up for when they came into this room to help me out. So during the exercise section, put up a red sticky. When you get done with the exercises, I may ask you to put up a green sticky. I'll talk about that later, though. While I'm typing, I'd love you to just shout things out. While we're working through the exercises, there is a test framework. Who has practiced test-driven development? TDD. Well, that's a lot of you. Congratulations. For those of you who haven't, that is perfectly okay. You don't need to practice TDD. We are practicing TDD during the exercises, though. For those who've done testing, what's the tricky part of tests, of writing tests and doing test-driven development? Writing tests that fail, yeah. I would actually say the trickiest part in general is even simpler than that. It's even writing the tests. The hard part of test-driven development is writing the test. That's why those of you who didn't raise your hands probably don't do it, because test-driven development is hard. You've got to write tests, watch them fail, get your code to pass. So I've done the hard part. I wrote the test. It's your job to write the code to get the test to pass. So during the first exercise section, you'll see what I'm talking about. That's not zip file. We're not going to get to that quite yet, though. All right, we are going to dive into things. Before I do, any questions or concerns about things in general before we get started? Yep. It is right there. http://pycon2018.trey.io. Yeah, if you came in the room not knowing that, that's good, because I didn't announce that before you came in here. So you were all on the same page. So that is the class website. That is what you're going to use to get the exercises. You will eventually be able to go back and reflect on what we've done today through the video and through class notes there. All right, I'm going to say we have a list. So we have a list of names here. So various names in this list. If I wanted to take each of the names in this list and print them out, how could I do that? A for loop. So in Python, I could do this. I should have probably brought a keyboard that I'm more comfortable typing on. This is going to be fun. All right, this is a for loop. It's printing out our names. What is a little bit odd about this for loop? Anyone know? Yeah, so instead, range here, what could I have done instead? Yeah, for name in names. And then what do I do here? Someone else. Print name. So I'm in Python 3, so I'm using the print function. So in Python, we have a for loop. It is not like a traditional C-style for loop. It is a for each loop, as it's called in some other languages, or a for in loop in Python, or just a for loop as we call it. It is not a for loop that has indexes. So we're going to be doing things this way here for name and names. So for loops, if you don't know this part, the rest of the tutorial is going to be a little bit fast-paced and tricky for you. I'm assuming knowledge of for loops here, so if you don't know this, be aware that it's going to be tricky. You are perfectly, I want you to stay in this room. Don't leave this room. I mean, you're welcome to leave this room. You can leave if you would like at any time. The door is not locked yet. But yeah, only during the exercise sections do we lock the door to make sure you do the exercises. But know that you're going to have a little bit of a struggle if you don't know about loops yet, because I'm kind of assuming that knowledge. I had to start somewhere here. Okay, so if we have, if we do want to use indexes, if for some reason we do want to use indexes, for example, maybe we have a list of colors, and then we have a list of numbers, and we want to say, you know, we'd like to take those numbers and match them up with a corresponding color. So if I did want an index, I could say, for I in range of len colors, and print, and I typed ratios instead of ratios, so I'm going to have to misspell that properly here. I could do this. What is another way I could get an index in Python? Enumerate. So I could say for I in enumerate, wow, I'm doing great at spelling today. Enumerate colors. And then what could I say, what could I change here? Yeah, so this I thing here, you're right. I put this in a tuple. This does not work. What was I supposed to do here? Yeah, for I something. So that something is going to be a color. So when I'm printing here, instead of colors I could just say color. Print color, we get the corresponding ration. That's what we're calling ratios now because I misspelled it. How else could I do this? What is it I'm actually trying to do here? I'm getting an index. What's the index for? I could zip them. Yeah, that was an answer from a TA, I believe. So that was a little bit of cheating, but that's okay. You all stared at this. You didn't know the answer. and a TA came in and helped. So for I color and enumerate colors, I could instead say for color ratio in, does anyone know this part? Yeah, zip of colors, comma, ratios. You're right, it is rations. There we go. We're going to consistently, I'm going to maybe spell this correctly next time. So print color and ratio here. So we're looping over two lists at the same time. Zip is made for that. So I want to make clear here, we're reviewing loops. There's a lot of looping stuff that is relevant in comprehension. So I want to review this. When you need an index, you can use enumerate. You don't need to use that range of len. Enumerate's the idiomatic way, the preferred way. When you need to loop over two things at the same time, you probably want to reach for an index if you're used to another programming language or if that's the way your brain's working there. Zip is meant for that, though. We can loop over two things at the same time with zip. Questions? As you were asking questions, I'm going to keep typing. Any questions? Yep. Do they have to have the same number of objects? So when we're doing zip here, this is a great question. We've got colors and rations. If I said ratios equals, and I'm going to do, this is a Python 3 syntax here. Rations, I'm throwing into this list here. I'm going to add another ratio at the end. We'll say 10. So we got ratios and colors. There are more ratios than colors. There's 4 of those, 3 colors. If I do this zip thing, what do you think is going to happen if I loop over now colors and ratios? Same thing that happened previously. That's one possible thing. What else could happen? Duplicate a color. So maybe we'll take the last color possibly there and put it with ratios. What else might happen here? An error. Maybe it gives us an error because they're not the same length. Other ideas? Index outside of range error. Okay. So what Python chose to do here of the possibilities is it stops at the shortest one. So zip stops at the shortest one. There is a way to go longer. There is a thing called zip longest. You can look that up on your own, but zip stops at the shortest one. Great question. Other questions?
Can it take n number of args and zip across many things?
Yes, yeah. So actually, if I do help on zip, this is something we're allowed to do in our REPL. There's a help function. This gets you sort of what the Python documentation tells you. Sometimes it is worse than the Python documentation. Sometimes it's the same. Zip tells you return a zip object whose dunder next method returns it. So I'm going to not read that because that's a little confusing. The thing we care about is this up here. Zip iter1, iter2, ... Those square brackets mean it's optional, and the ... is any number of these. So zip actually does take any number of lists, or really any number of iterables of anything that we can iterate over, whether a list, a set, a string, anything we can iterate over. Other questions? All right, we'll do more questions in a bit. So this is what? What is the type of this thing? This is a dictionary. So for item in, we'll say for item in animals, can we loop over a dictionary? Does this work? What's your guess? Okay, so we think this will work. What possible things could this do? So if we say I have this. Yeah, so it could give us keys, could give us values. What else could it do? Could give us both, yeah, key value pairs, maybe in tuples. Could give us an error. Maybe we can't actually loop over a dictionary this way. Other ideas? Could print out hello world just for fun. So for item in animals, we have keys. We have birds, cats, dogs. We ignore the values entirely. When we loop over a dictionary, we get keys. So if we wanted to, we could say I have a certain number of these by looking up the item in this animal's dictionary here. So this would be item, the count of these, and the actual animal. I have 3 birds there, so it's looking up the value in that dictionary and getting the item. What is this F thing that I typed? Anyone know? Yeah, an F string. F, as I learned in a tutorial this morning, stands for fantastic, I think. These are fantastic strings. Some people call them format strings. Fantastic string sounds cooler because they are fantastic. This is a Python 3.6 thing. If you're not on 3.6, you're going to have to use the format method. It works similarly to this. Not quite the same, though. Okay, this is not the best way to loop over dictionaries, though. Anyone know another way to loop over dictionaries? We want both keys and values. So for key value in animals, yeah, let's try that. So this here, if we do for key value in animals, it doesn't actually work. It says too many values to unpack. The reason for that is it's trying to unpack a string into these two things. This is close, though. Dot items. So when we loop over a dictionary, it always gives us the keys. We can't take the keys and make them into key values. If we want the key value pairs, though, if we take items, it gives us essentially a list of key value pairs, or really an iterable of key value pairs. So we could do the same F string up here, but this is a little bit more readable. I have key value, or in this case, value key. Now, value and key are awful variable names. I wouldn't recommend using this. You could instead say, for example, what is key? What does this represent here? An animal. What is this one? Some kind of number. I'm going to say it's a count. Maybe the number of times we see that animal. So we've got count and the animal there. You don't have to name your variables well. I would encourage you to do so. Questions on anything related to loops? We're going to jump into comprehensions in a moment. So we've talked about enumerate. We've talked about zip. We've talked about looping over dictionaries. This is a lot of looping review here. Any questions on any of this? Yep. The web address is pycon2018.trey.io. That is the class website. And I'll put that back up on the screen again when we do exercises. All right, so I have some numbers, my favorite numbers here. If I wanted to make a new list of numbers that contained these numbers multiplied by 2, how could I do that with a for loop? What's the first thing I need to make here? This doubled numbers thing here, what thing should it be? A list. An empty list or a list with things in it? Yes, I could do that. I'm going to do that in a moment. That is a list comprehension. If I'm not using a list comprehension, the only thing that I know how to do so far is use a for loop. Using a for loop, I need to make an empty list here. For n in my favorite numbers, what is the thing I want to do in this loop? If you've seen a list before, append, doubled numbers dot append, and I'm going to say n times 2. So I have just taken numbers, all the numbers in my favorite numbers, multiplied them by 2 while sticking them in this new list here. Python has a shorter way to do this. This is the entire reason we are in this room together here, list comprehensions, and a little bit more than that. So what is the syntax here? You just said it earlier. Yep, so n multiplied by 2. So you notice here, this is the same as the for loop, but there's some things different. What is different about this comprehension here than that for loop? The operator's at the beginning. We've got n times 2 at the beginning, whereas it's sort of at the end in the for loop. What else is different? What are we missing? There's no append. We don't use the word append at all in here. There's no colon. Yeah, we don't have to create a new list here at all. There's no empty list beforehand. In fact, we're kind of repeating doubled numbers up there. We say doubled numbers equals an empty string, or an empty list there. Doubled numbers not append. We've only got one doubled numbers down here. So this comprehension, we didn't even make a variable. Oops. We didn't even make a variable until we made the list, and then we stuck it in a variable there. So it did all the work of making that new list for us. Okay, so this is a list comprehension. I'd like you to know here, this is an important point that I'd like you to memorize, or at least try to memorize by the end of today. If this is the one thing that you get, I want you to get a recipe out of this. So my favorite numbers, this double numbers thing here, I'm going to copy our for loop, and I'm going to do something to this to turn it into a comprehension. So doubled numbers equals this empty list for n and my favorite numbers, which I've got to go grab my favorite numbers here. We're going to append over and over to this list as we're looping. I want to copy-paste this into a comprehension. So the thing that I want you to get out of this is to know that whenever you see something like this, an empty list, looping, and then appending, you can copy-paste your way into a comprehension. What is the first thing that I need when I'm typing out the line of code for this comprehension? Yeah, the list I need to store this in, or the variable. So I'm going to copy doubled numbers equals, and then this empty list. In here, I'm now going to copy something else. What's the next thing that goes in that comprehension? N times 2, the thing inside append. Whatever it is we're sticking in that append function call goes next. What next? The 4. Everything but that colon there in the 4. So a list comprehension, if you can write a for loop in this syntax, you can copy-paste your way into a list comprehension. So while you're copy-pasting this, I'm going to undo this, and I want to show you how to do this in a better way. This is something that's easier to notice when you're copy-pasting. Double numbers equals this. I'm going to write this on multiple lines of code. The next thing I'm copying is the same thing. It's this thing I'm appending. And then I'm going to take this without the colon and paste that as well. This works just the same. How do I know? So Python, does Python care about white space at all? Yes. Yeah, it cares a lot about white space in some ways. Indentation is white space specific. Python doesn't care about this white space. You're allowed to write your code like this if you wanted to. Don't write your code like that. It's a little weird, but you're allowed to. Why are you allowed to do that? Yeah, it's inside these square brackets. Python, as long as we've got an open bracket, brace, or parenthesis, we're allowed to put as much white space as we want in there, and it doesn't care so much. So double numbers equals this list n times 2 for n and my favorite numbers. This is a list comprehension that we've copy-pasted our way into that's equivalent to that for loop. I would recommend, as you're working through exercises, you write most of your list comprehensions this way, or at least try it out this way on this multi-line notation, as well as this single-line notation. See which way you like better for different situations. Sometimes this will be more readable. Sometimes the multi-line way will be more readable. I usually prefer the multi-line way, personally, in many cases. Questions about this? Yep?
Finally, both the types of solutions are doing the same thing, right? Why is the list comprehension more efficient than the normal?
All right, so the question is, this up here is doing the same thing as this here. Why is this one more efficient or preferred? What's better about this? Is that right? So that's a great question. This here, any ideas about why this might be better? Thoughts on or guesses as to why one would ever write their code this way as opposed to this way? What was that? Editability, so maybe it's easier to edit it? Okay. So sort of maintainability in there. What other ideas? The processing time, so maybe this one's faster possibly than a loop. Is that what your guess is? Yeah, that could be it. What else? What other things might be going on? So we got editability, readability, which is similar to editability, maybe performance, possibly writability. Maybe some people like writing this better than this because there's fewer characters to type. So this does happen to be faster in many cases. I would argue, though, that you shouldn't be writing list comprehensions for their speed, because the speed is often a negligible difference. There's often ways to make your for loop about as fast as a comprehension. The reason I often prefer comprehensions is their readability, and not necessarily even their readability, their sort of along with maintainability, the fact that they allow you to write your code in a somewhat fundamentally different way. And you're going to see that as we go on here, that your mental model about the way you look at your code can shift, especially as you get to generator expressions. They allow you to write your code in a way that is different from the reader's perspective. So here, when we have a loop, what do we know that we're doing when we have a loop? I'm looping over probably a list, some kind of thing that I'm looping over. Am I appending things? Am I adding to a new list when I'm looping? Yeah. Can I do something besides add to a new list when I'm looping? I could print stuff out. In a list comprehension, what's the point of a list comprehension? Building lists. We're looping over one list or list-like thing and building up a new one. Loops have a more general purpose. What's the point of a loop? Iterating over something and doing a thing. That thing could be adding to a new list, it could be printing, it could be lots of things. Doing something over and over based on what is in some other list or iterable. So list comprehensions are a special purpose tool. They're a specific special purpose construct. For loops are a more general purpose tool. So this is a special purpose tool. It is meant for looping over one list, making a new list out of it. So if you've got a whole bunch of for loops in your code, and you could turn those into comprehensions, and there's a couple for loops that you can't, when you spot in code a for loop amongst a bunch of comprehensions, you could probably go, oh, there's something more complex that might be going on here than just taking one list and making a new one. Whereas when you spot this, your eye and your brain can hopefully say, you know what, I know what I'm supposed to be doing here is looping over one thing, making a new one. I'm taking one list, changing some stuff in there as I build up a new list. So that's the main reason I would suggest you focus on list comprehensions. It's not necessarily performance, but for the fact that they allow you to shift the way you think about your code. You might find them uglier, less readable. I hope during some of the exercises, you will find when you refactor your code, when you copy paste it from a loop to a comprehension, you will occasionally say, oh, that was actually much more readable in this particular case. This case here, maybe not so much. Maybe this simple case isn't so complex with this for loop that you'd prefer a comprehension. There are cases, though, where it can really make things a little bit more readable. Other questions? Yep? Performance to a map, yeah. So I'm thinking here, that is something that I don't have curriculum on actually here. So map, for those who are unfamiliar with this, I'm guessing many of you, because this is kind of a functional programming concept in Python, you can say map lambda n colon n squared, or n times 2 rather, for my favorite numbers. The thing we get back is a map object. If I want a list, I can convert it to a list like this, and I get the same result. Performance-wise, it should be faster than map, because map is calling a function over and over. However, again, if we're not focusing on performance, because that can sometimes be optimized in other ways, I would prefer a list comprehension for another reason. What is awkward about map? It's kind of ugly. Yeah, we've got the same parts here, n squared for n in my favorite numbers, but we don't have a lambda. What is a lambda? An anonymous function. Who has never heard of an anonymous function before? This is a weird new term. Yeah, there's at least a few of you in the room. You do not have to be doing Python for a while, or rather you can have been doing Python for a while and have never seen or known what a lambda really is. Lambda is weird. So lambda is one of those things you see a lot with map. Who has never seen map before this? So you've seen map, but you never really knew what it was, maybe. So you're not really so comfortable with map. Yeah, that's a lot of you. So map here, if you see this, you have to figure out what is going on with this map. If you see this, and you've never seen a comprehension before, you can probably guess there's looping happening. Maybe we're building up a new list. This is a little bit easier to guess about, I would argue. So that's another reason I prefer comprehension over map, is map is a more functional style of programming. This is still a functional style of programming, but this is a special syntax for doing the thing that map is doing. Other questions? These are great questions, by the way, because these are things that I wanted to address that we can address in the moment as you have these questions here. All right, there is a part of a comprehension I've been leaving out so far. What else can you do with a comprehension that I haven't shown? For those who has written a comprehension before and you're here just for fun, cool. At some point, if you're bored, you can help other people in the room. However, we are going to go into some things that are maybe a little bit more advanced than you've done, so I'm hoping you will get something out of this. For those who've done comprehensions, what else is in a comprehension that I could add here? Yeah, a filter, a condition. So I can do, in addition to mapping, this is the mapping portion of a comprehension, the n times 2, if you'd like to think of it that way, there is a filter portion of it, which is to say maybe I only want to double the odd numbers. So if n mod 2 equals 1. So I'm doubling the numbers, but if we look at my favorite numbers, we'll see that most of those are even there. Yeah, except for we've got or most of those are odd, except we've got two even numbers, 2 and 8. So this here is another optional part of a comprehension. Now, I showed this a little bit backwards. The reason I say backwards is, again, I would like you to, during the exercise section, copy-paste your way into a comprehension. So the way I'm going to write this comprehension with a for loop is like this. I'm going to say double numbers, for n. What am I going to do to this loop to make it do the same thing as that comprehension I just had? Yeah, the same if n mod 2 equals 1, what else do I have to do? Indent this code. So white space, it matters when we are indenting. This doubled numbers here, I'm going to do the same thing, copy paste our way into it. I copy the double numbers equals the square brackets. I put an empty line there. What's the next thing I'm going to copy? Yeah, the thing we're appending. What next of our two lines that remain? Then the for, and lastly, the if. So we've got things, again, a little bit out of order. The append goes first, then we've got the for, then we've got the if, but we can copy paste our way from this to this. Whenever you have empty list, looping over something, if statement, append, you can copy paste that into a comprehension. If you cannot figure out how to write your code this way, you can't write your code this way. So this is equivalent here. This comprehension is equivalent to this for loop. Questions? So this filter part is optional. Is the mapping part optional? N times 2? Do I have to change the thing? What if I didn't want to change it? What would I do? Yeah, this looks a little awkward. N for n in my favorite numbers if n mod 2. So if you ever see something, x for x in something, we're going to talk about that syntax later. Unless there's a filter, that's not so necessary, and we'll talk about that later. But usually you see a filter, x for x in something if some condition on x, whether it's equal to 1 when you mod it by 2 or something else. Questions? We are going to have exercises in a moment here. I'm going to check how we're doing on time real quick. All right, so our exercises are on the website, which I'm going to put up again. They are at list comprehensions, comprehension exercises. So the website URL, again, is pycon2018.trey.io. List comprehensions, comprehension exercises. And the first exercise I'd like you to go through there is starting with a vowel. If you get through, they're starting with a vowel, power list by index, flatten a matrix, reverse difference, matrix addition, transpose, factors, and Pythagorean triples. You're not going to be able to get through all those exercises. Regardless of how long I give you, you will probably not get through all those exercises. The amount of time I'm going to give you here is going to be 15 to 20 minutes. So I will at least give you 15 minutes here. So until 2:10. So at least 15 minutes there. If you have a question while you're working through these exercises, what can you do to get someone's attention? Print statement. I don't know, I might have misunderstood that, but I like that answer. Not Python 3, we're in Python 2, we're doing print statements, and we have a question. I think I might have misunderstood there. So if you have a question, you can put up a red sticky on the top of your laptop, sticking up like this. The orange sticky means nothing. I think the last room had orange stickies, so I stuck that on my laptop. I would like you to put up a green sticky if you get through the first exercise. When you finish starting with a vowel, I'd like you to put up a green sticky. And actually, I'm going to modify that because we've got 15 minutes here. When you get through, if you manage to get through the first 3 exercises, starting with a vowel, power list by index, and flatten, put up a green sticky. So put up a green sticky if you finish past flatten a matrix. So put up a green sticky if you finish past flatten a matrix, put up a red sticky whenever you need help. we have 5 TAs and me, and I'm going to be wandering around the room as well. There are 6 of us here. We want to help you. So when you have any question about anything at all, feel free to raise your hand or put up a red sticky, get our attention in some way, and we will wander over and chat with you. If you have a question about something that has nothing to do with this class, about how to write Python code in a readable style, about your feelings, or something that you'd like to talk about, that the rest of the conference, what it's going to be like, put up a red sticky. The TAs need something to do. They're in the back of the room. They want to chat with you. So I will be wandering around the room. We're going to be wandering around the room here, and you'll be working through exercises. Put up a red sticky whenever you have a question. Something I forgot to remind you all of, I said this at the beginning. As you're working through the exercises, where are you typing this code? Yeah, so there is a zip file. It is on the website. It is not on this page on the website. The test framework is a scary sounding page that you don't need to read all of. I don't assume you'll read it because I don't tend to read things that are on the internet so much. I skim them, so I assume you'll skim that page too. Go to the test framework, click on the exercises zip file that is on that page. It's at the very top. It says download the exercises test files. Download and extract that zip file. Download and extract that zip file. In that zip file, what you are looking for is a file. What is it called for this first section? Lists.py. So you're going to edit list.py. There is a skeleton. There is a skeleton of this function. What I mean by a skeleton of this function is it says def get val names. You have to type the rest of it. So edit list.py, get val names, and run the tests. Running the test, there are instructions on the website. It is a weird test framework. If you've done TDD before, you're probably going to be a little bit confused because my form of testing here allows the test framework to know both the name of the exercise and where it lives and where those tests are. So follow the instructions on the website. When you get stuck, I'm assuming you will get stuck. When you do, put up a red sticky, and we will come by and help you out. So if you are confused right now, stick up that red sticky, and we will come around the room and help you out. don't see any green stickies up, so no one's done flatten a matrix yet, which is good. If you've done flatten a matrix, put up a green sticky just to indicate to me if you could. Done flatten a matrix. So a couple of you have done flatten a matrix. The rest of you are all on the same page. You're probably on that first one there, get val names. Maybe you've gone to power list by index there. Any questions at all, put up a red sticky. We're going to regroup in a moment here and solve this together, so I'd love to help you individually first. Yeah, y'all are confusing me with your stickies on the sides of your laptops. The TAs know what's going on. I'm just confused at the moment. So we're going to solve this one together here. I hope you've tried to struggle through this. If you didn't solve it, that is perfectly fine. We're going to try to solve it together. You know some things that have failed at least. So what we're going to do is I actually have to go get the exercises zip file, which you'd think I would have, but I didn't download it. Apparently I wasn't even on the Wi-Fi up to this point. I just went a good hour without being on the internet. That's amazing to me. I'm proud of myself. Thank you. I was not on the internet. Oops. I'm saving the zip file from the internet now that I'm on it. I'm extracting this, which you can't see this, in the directory that I'm currently in here. I didn't tell you where to extract it. I hope you put it somewhere good, like desktop or documents, and not system32 or your root directory on your machine, which I guess is okay if you have root access. Maybe your temp directory, you want it to be deleted. Whenever your computer restarts, you're playing on hard mode. When your computer crashes, your files go away. Put it somewhere useful, like your desktop, documents, somewhere like that. So this zip file, we have in the exercises directory here our test.py. Test.py is not what we are editing, it's what we're running from the command line. So I'm going to type python test.py, and what am I typing next to run this first exercise? Yeah, get _ val _ names. So our tests fail. So this is going to be a little bit tight here because I've got a very large font size here. What file am I editing? Lists.py. So it said this on the website. List.py, get val names. This is the function I'm going to edit. All right, this function here, our tests fail. It says get val names takes 0 or takes no arguments, 1 was given. What do I do to get this test to not say that error? What's the first thing I need to do? Yeah, it's got to take an argument here. So before we keep going, I'm going to ask you something. Who likes answering questions? Who's a fan of answering questions? All right, Russell's a fan of answering questions. Good. I'm glad one of our TAs likes answering questions. It's good to answer questions if you're a TA. Who likes raising your hand? You enjoy raising your hand? Cool, awesome. Who's not so big on answering questions? Yeah, not so big on that. All right, who's not a fan of raising your hand? Thank you for raising your hand. Even though you're not a fan of it, you just went out and you raised your hand for me. I appreciate that. I'd like to challenge all of you today. If you are not a big fan of raising your hand or answering questions and just shouting things out, try to do that at least a couple times today. To go out on a limb and say, I'm going to guess this is what maybe happened, especially when I give you some leeway by saying, what could happen here? You're allowed to shout ridiculous things out during those moments. So yeah, cheesecake could happen. We could print out hello world, we could print out cheesecake. So I'd like you, if you are not a fan of answering questions, raising your hand, shout something out at least once or twice today. On the other hand, if you are a fan of answering questions and raising your hand, I would like you to try to pause, count to 10 or so, not out loud. Don't count to 10 out loud. That will be a little bit weird maybe. Fingers in your head, and then after no one else has shouted something out, maybe throw out your answer out there if no one said it so far. Or repeat someone else's answer, that's fine too, especially if I didn't hear it. So I'd like to challenge all of you, if you're not a big fan of answering questions, raising your hand, try to participate a little bit more. If you're big on participation, pause, leave a little bit of space for others who are not so keen on that. Okay, so the reason I ask that is that you do not learn from putting information in your head. Anyone know how you learn? By doing, by teaching, which is why I'm up here because I wanted to learn. I'm teaching you, which is true. You are teaching, or you learn by teaching. The reason you learn by teaching and the reason you learn by doing is you learn by taking information out of your head. You are attempting to retrieve information and practice that retrieval. So you don't learn from putting information in your head, you learn from attempting to take it out of your head. And when I ask you what might happen and you shout something out, you have to take something out of your head to do that. So I'd like you to practice taking things out of your head and not shoving stuff in your head here as we're learning. Even if it's the wrong answer, try to take that thing out of your head, even if it's the wrong answer. You'll leave a space for the correct answer once you get to it. So get val names. We're taking a single argument here, name. This is not supposed to be name. What should this be? Names. That doesn't matter. It's just a variable name. Variable names are important, though. They have meaning because it lets us know what our code's supposed to do. What type of things should names be? Okay, so if I return names, I should see a list of all of the names. What is the correct list I'm supposed to return? What should be different about this? Yeah, it's supposed to have vowels. It's just the names that have vowels in them. So what's the first thing I want to do here? If I want to make a list with vowel names. Yeah, I need a new list. So I'm going to call this, you can call this whatever you want, val names equals a new list. Now I'm going to do this without a comprehension. Why am I doing this without a comprehension? So I can copy paste it, exactly. I'm writing it with a for loop because you're comfortable with that, hopefully. If you're comfortable with a for loop, you can then copy paste that into a comprehension. So val names equals this. What's the next thing I'm going to do? For those of you who are, for name and names. So for those of you who are not so keen on shouting something out, but you think you might know the answer to this one, what is the next thing I might do here? In my for loop, what's the thing I'm going to want to do every time I'm looping? Those of you hiding in the back of the room, you're allowed to shout things out. Check to see if the name starts with a vowel. Yeah, so if something. Now this part is the tricky part. You probably all got slightly different answers because there are a lot of ways to do this. What is one way I could maybe check to see if the name starts with a vowel? Something you tried, regardless of whether it worked. Starts with. So name dot, there's actually a starts with method on strings. We can say if the name starts with, and what did you pass to starts with? A string, a list, a dictionary, a tuple. What kind of thing was this? A string. So a string of the vowels, like that. Let's see, if the name starts with this, then val names dot append that name. What do I want to return here? Yeah, val names. I don't want to return the original list, I want to return val names. So this is one way we could try to do it. Let's see if this works. That does not work. We get an empty list. Did anyone use starts with successfully? How'd you do it? By a comma, like this. All right. Put it in a variable, yeah. So what's happening here is we're actually not passing them to this function as separate arguments. This is actually a tuple. So starts with requires a tuple to be passed to it, a tuple of all the possible substrings that it might start with. So it was accepting A, I, O, U. What was the one name that it would allow us to do when we had starts with the string A, E, I, O, U? What kinds of names was this accepting? Yeah, strings that start with AU. That start with A, E, I, O, U. It had to be a string that was exactly A, E, I, O, U at the beginning. So this here is any of these options of A or E or I or U or O. We've got one failure here. What's this failure about? Yeah, we have a lowercase letter. So I would have to put the uppercase and the lowercase letters. That's a little bit annoying. What else could I do? Dot lower. Where would I do that? Yeah, so name dot lower, this gives us back what type of thing? Yeah, a string, a lowercase version of this. So we've got a lowercase version. We've got uppercase letters, though, so I'm going to do the opposite. I'm going to do dot upper. And that passes our test there. We have 3 tests that passed. Okay. How else did you do this besides starts with? Anyone find another way? Name 0. So you did name 0. Lowercase it. Got it. So uppercase it, name 0. So one way you could do this is 0 equals A. Or name 0 dot upper, name dot upper 0 equals E. Or how could you do it without all these ors? Yeah, so we've got in Python containment. So this in operator is containment. Uppercasing it, checking if it is in this val names. And again, it fails. How does it fail here? Thank you. Forgot the 0. Does it matter where the 0 goes? Could I put it over here? What's your guess? Who thinks this is going to work? Name 0 dot upper. Who thinks this will not work? This is going to give us some kind of error. Yeah, so when we index a string, what type of thing do we get back? A letter, a character, a string. You gave me all 3 guesses. You're ambitious. Yeah, so we've got a character, a letter, a string. It could be some kind of type here. The thing we get back in Python, name sub 0, name with those bracket zeros, is actually a string. So in Python, you're allowed to say name 0, the type of this thing is strings. What is this going to give me? The first letter of the string T. So you can do this for forever. Strings give you strings back when you index them, so they're as long as you want to go. We're not going to do this. This is weird to do, but know that strings, when you index them, give you strings back. So it doesn't matter where that 0 goes. That's up to code style. That's up to you, however you want to do that. Questions? Questions on this one? What am I missing in this function? Yep. It is not. The reason is I wrote name and not names. So I said for name and names, if you wanted to, you could say for x and names, for n and names. I happen to use 2 variables that are very close to each other there. If you wrote your code like this, it's probably a little bit more obvious. This for x and names, as we loop, we get out the individual names. This x here, sub 0, that gives us the first character of each name. So if I said names 0, 0, what would that give me? What's your guess? What does name 0 give me? The first name in that names list. Name 0, 0 gives me the first character of the first name. So we're doing for name and names, which means we can say name sub 0 dot upper. Other questions? So what is this function missing? What are we learning about that we haven't used here? List comprehensions. List comprehensions are the last thing for you to think about. For loops, there's lots of different ways to write for loops. There's lots of different ways to write comprehensions. Before we copy paste, I'm doing the work of figuring out how we're going to write our code. Then I finally copy paste. All right, we're going to copy paste this into a comprehension. What is the first thing I copy? Yeah, the variable name. Val names equals these square brackets, or what I want there. What is the next thing I'm going to copy? I'm going to do this over multiple lines. Name. Name because it's the thing I'm appending. What next? For. And what after that? The if, the condition. So name, for name and names, and then we've got that condition. Val names equals this. I can delete this. It is equivalent to that comprehension. Cool. Are we done? Our test pass, I see a little OK there. Is there anything else we could do to this function? Straight away return it. So we've got val names equals this thing. We don't even need that variable. Our function name is get val names. It should be clear what we're returning. We're returning val names. Just return this. We don't even need that variable there. Questions? All right, so I'm going to ask a question here. You're allowed to answer it either yes or no. I guess you can answer it maybe. I'm not going to be offended, whatever your answer is. Who thinks that this is more readable than that for loop at the moment? You're thinking, you know, I like this better than that for loop. I'm a fan of this style of coding. I'm gonna have three possible answers here, I guess. So feel free to answer twice. Who's not so sure about this? You don't know whether you like this better than a for loop. Okay. Who doesn't think this is better than a for loop? You find a for loop more clear than this. Okay. Only a few brave people who wanted to raise your hand for that. This is a comprehension. Regardless of whether you think this is more readable, you're going to learn about why these things are kind of the next step in evolution for your for loops when you're building up a new list. We're going to get to that in the next section here in a little bit. Did anyone get to flatten? Who got stuck on flatten? Yeah, so we're going to do flatten together real quick here. So we're skipping power list. The reason I want to do flatten, what does flatten accept? A matrix. What do I mean by matrix? A list of lists. So a list of lists of numbers, a list of lists of something. It's a list of lists. What type of thing does it return? A flattened list. So a list that doesn't have lists inside it, or at least it's flattened one level. So I'm going to call this flattened, this variable here. It's going to be an empty list. We're going to do this with a for loop. How would we do this with a for loop? What's the first thing I need to loop over? What's the only thing I can loop over at this point? Yeah, we got a matrix, so I can say for row and matrix, what could I do here? I can do another for loop. For x in row, then what? Yeah, flattened.append x. We've got a loop with appending going on. How else could we write that? We could write it with a list comprehension. If we're in for loop land, is there another way to write this code? I think I heard someone whisper it. Could use lambda, could use zip. So the answer I'm looking for, you might have seen this before, flatten.extend. We can take one list and extend a list by it. So if you wrote your code this way, if I call flatten, we see an OK there. It does pass the test. This code actually works. Can I copy paste this into a list comprehension? No, why not? What am I missing? Append. I don't have any append in here. I'm going to undo this change and write my code this way, which looks a little weird because extend was kind of a nice way to write that. But we're preparing ourselves to copy paste into a comprehension. So our code still works. What is the first thing that we have to copy if we're copy pasting? You probably don't know the answer to this one. What's the first thing that we're probably going to copy, though? Yeah, so the thing we're appending, that comes right after I heard someone say this, the variable name, those brackets there. So the square brackets, then the thing we're appending. x. I'm going to call it item, because I think this is probably a better name, a little bit better than x. So we've got item there. What's the next thing I might copy paste? What is your guess? The outer for loop. Okay, let's try that for row and matrix. Then the inner one for item and row. Let's see if this works. So that did work. For those of you who didn't get this right, what did you do wrong? Flip the fours. Why did you flip the fours? Flip the floors. Why did you flip the for loops? What was your intuition there telling you?
I normally go because it's hard to explain. Basically, you start with your output, and then the for loop. The inner for loop seems to be logical since you also do.
Right. So if we're reading this in English, the way I do this in my head, the reason it confuses me, if I were to say this in English, I would say item for item and row for row and matrix. Python does not like that. It fails and says local variable row reference before assignment, which is not particularly helpful. It's a little bit helpful there, but it doesn't tell us what the problem is. The problem is Python is executing in the same order it was with our for loop. So this is the reason I recommend copy pasting from a for loop to a comprehension. You're going to paste things in hopefully the right order. I do not see this as English here. This is no longer English to me. This is Python. Item for row and matrix for item and row. It sounds awkward, but it's the way we have to write it. Questions about this? Yep.
Trey, is it the case that you want the mental model of what Python is doing? In this comprehension, it literally is for the last two lines of this comprehension is that we first assign variable row and then loop over row. So that's basically like how Python.
Yeah, so if you want, and I've seen people do this, if you wanted to indent your code kind of the way Python sees it, you could do this. Item for row and matrix. Inside that loop, you've got for item and row. I've seen people write comprehensions this way. Remember, this is not indentation here. I just said indent, even though it's not indentation, because my mind's thinking that way. This is alignment. This is for us, though, for us to see this the way we want to see it, which in my mind, I prefer it like this. A lot of people like it like this, though, because this makes it a little bit more clear. We've got for row and matrix, and then we're looping over the row to get the item, and then we're using the item first, which is the thing that's kind of backwards about comprehensions. Take the last thing, put it first. Other questions? Yep.
Sorry, and another general question I think might come up is when we're writing the difference choosing between forms of comprehensions, is the goal basically optimize readability first?
Yes, yeah, readability is the thing I would like you to optimize for. Performance after readability, readability first. When you're choosing how you want to write your code here. And actually, in a moment, we're going to talk about writing our code in a couple different ways when we have a couple different options with comprehensions. What else could I do with this function? Yeah, I don't need that flattened variable. I could just return the new list I'm making right away. So I'm going to undent this because I prefer it this way. And our tests do pass there. Other questions? Yep.
So if you're if that list, I guess, is null,
If the list is null, which list?
so if there's no rows or items, pass in some
So if we passed in an empty list? So if matrix was empty, what would happen with this comprehension? What do you think? What would happen with the for loop? Yeah, so we get for row and matrix, what's that going to do? Nothing. We made an empty list. We say for row and matrix, we do nothing. We return the empty list. The comprehension does exactly the same thing. It's equivalent to that for loop where we say for row and matrix, there's nothing there. Matrix, it isn't none, but it's an empty list there. So we have an empty list. We don't loop at all. We end up getting an empty list. So you're right. If we have an empty list, we get an empty list back there. If we have a list of empty lists, we get a list of empty lists back because it's only going to iterate as far as it can. Other questions? So I'm going to paste in some code here. We're going to sort of not quite switch gears here. We'll switch gears in a moment. I'm going to say, we'll call this negate. We have code that takes a matrix, meaning a list of lists, like this, and what is it going to do here? Anyone who can read this code and tell me what negative matrix should end up being at the end? Positives to negatives, negatives to positives. Is it going to flatten the list, or is it going to be the same structure? Flatten it. It's going to flatten it. Same structure. Yeah, it's kind of hard to tell here because we've got negative matrix equals empty list for row and matrix. We have a new empty list there, so maybe it's not going to flatten. For n and row, we append to the new row, and then we take the new row, append to the matrix. So what we're doing here is we're taking our original matrix, making a new list, and then for each of the lists inside it, making a new list, and negating each of those items and sticking it in that inner new list, and then sticking the inner new list inside the outer one. We end up with a negated version. What here looks like something that could maybe be made into a comprehension, any portion of this code, where we're doing, what's the recipe for a comprehension? If we've got a for loop, we could copy paste into it. What is it? What should it look like? We have a loop. Is there anything we need before the loop? Yeah, making a new list. So we're making a new list, we're looping. What's the thing we should be doing in the loop? There's two possibilities. Appending, that is one thing that should always be happening. What else could be happening? Some kind of condition. We don't have any if statements here at all. There's no conditions. So what here looks like it might be copy-pastable into a comprehension? Guesses, lines of code. 5, 6, and 7. So we've got a new list, looping append. So I'm going to separate this a little bit. So copy-pasting my way into a comprehension. New row equals this. I'm going to leave this on one line of code instead of multi-line. You'll see why in a moment. What's the next thing I'm going to copy-paste? The thing I'm appending? So negative n, what next? The 4 for n in row. So this here is equivalent to what we just had. How else could I write this? Thoughts, guesses? Put the list inside the append. I like that idea. So we're getting rid of this variable we don't really need. We could stick that list comprehension right inside the append. Oops, that's the same code. So that works as well. Anything else I could do with this? Other ideas? Could I make negative matrix a comprehension? I don't know. What do you think? Yeah, so comprehension, we've got a new list, we're looping, we're appending. So what's the first thing I would copy paste? The other list comprehension, yeah. So we first need those brackets, then inside that, this other list comprehension, because, why am I copy pasting this? It's the thing I'm appending. It's the thing I'm putting in that new list every time. What next? The 4 for row and matrix. So this here is equivalent to that list of, or that loop of, the loop inside of a loop, the loop of loops, the loop inside of a loop that we had before. Questions on this? Thoughts on this? Yeah, so if this here was in this here, like this, yeah, what do you think? It looks like it succeeded. What is it doing? So what's going on there is I have a variable called row. It happened to be floating around in my REPL because we used it earlier when we had that for loop. Because for loops, the variables leak out of those for loops. This would give us an error if we didn't have that row variable, because it says row is not defined. I could take this 4 and stick it before this for loop here. So if I said negative in for row in matrix for n in row, this will actually work. Anyone want to guess what this will give me? It's going to flatten it. Sort of. It flattened it, and we stuck it inside a list. The reason is these square brackets out here, we don't have a comprehension here. What are we making on the outside? It's a list with a list comprehension inside it. So it matters where these 4s go. So this here is a list comprehension with 2 4s, meaning we've got a single list comprehension, 2 for loops inside it. This is a list comprehension with a list comprehension inside it. Questions on this? Comments, thoughts? While you're thinking of questions, I'd like you to ponder for a moment. The thing we started with here, who finds the first one here more readable? You think, you know what, I know what that does from glancing at it pretty quickly there. I know Python, I know the syntax. Who finds the second one more readable there? Who's kind of confused and you're not quite sure yet? Yeah, so that is absolutely an option where we could say, you know, we don't want to go all the way. I'm not so sure about this comprehension inside of a comprehension thing. That's confusing. I'd like to instead say, let's do the comprehension that was in here, negative n for n in row. I'm cheating and not copy pasting, but I think you get the idea. Negative matrix equals this empty list. This here, who finds this the most readable? A lot more hands there. So I prefer this one personally. I've been doing Python for a while, and I am a big fan of comprehensions. I'm not so big on this one. I think this is a lot going on in this loop. This one here I find perfectly readable as well, except that I'm actually missing a bracket there. So it's up to you how deep you want to go. But I want you to have the tools of recognizing there's an empty list, a loop, an append, maybe an if. That's copy-pastable into a comprehension. Oh, I have another one. I could go further. Do I want to go further is a different question than can you go further. Also note here, if I wanted to make a function called negate that negated everything in a list, I could absolutely write a function with a comprehension inside it and call that function here. I could, for example, say I want to make a negative matrix that takes a row and negates it. If you find this more readable, you could make a function that has this inside it. I'm not going to show you how to do that, but you can do that. That's perfectly possible. So list comprehensions are not the only way to chunk your code up. You can always write functions to make them even more readable if that's the case, if you find that more readable. All right, any questions before we kind of move on to another section here? So I am downloading a file, yep. Yep. Can you print columns without calculating the length using a list comprehension? So if we were to, you're asking if we could print, instead of printing out an individual row, print out the entire column. So I think what you're asking is if we have this matrix, could we print 1 negative 4? Yeah. Got it. Right, without calculating the length. We can do that. It's a little bit tricky, and it actually doesn't involve a comprehension so much. Anyone know what the answer to this might be? This is a weird one. So I showed you zip. Yeah, I think you probably knew the answer there. Zip here, if I pass matrix to it, it does not give me the answer. What is zip supposed to take? What do we usually pass to it? 2 lists, 3 lists. Instead of passing matrix, I'm going to pass matrix 0, matrix 1. Anyone know another way to do that? Instead of this, yeah, I heard someone say it. What's the operator we would use? Star. What this does is it takes the matrix. It takes matrix 0, matrix 1, matrix 2. It actually takes the length for us under the hood. takes each of the items in it, passes it to zip. Yeah, this is really cool. This is pretty nifty. You can take something, we're essentially transposing this matrix. We're taking the rows, making them into columns. What is different about this transposed version, though? What are those parentheses? Yeah, they're not lists, they're tuples. We may not care about that. If we care about it, we would have to turn them into lists. To do that, you could use a comprehension. You could say, let's loop over this new zipped thing, take the tuples, turn them into lists, make a new list of lists there. Using, for example, maybe you could go list of the column for column in this thing, something like that. So yeah, list comprehensions are nice when combined with other tools. Other questions? All right, so we're going to get to generator expressions in a moment here. I want to first show you some code that's going to kind of lead the way in here. So we will call this reverse.py. This code opens up a dictionary file, dictionary.txt, which I have downloaded. It is linked on the website. You do not need it because this is my code. You're not going to have to type this code out yourself. What is this with open thing doing? Anyone? Context manager, yeah. So that's what the with thing is. Open is opening the file, assigning it to dictionary file. The reason I'm using a context manager is it automatically closes the file for me. You don't have to know this syntax. Trust me, this is opening our dictionary file. And then we're doing something here. What is this giving us? As we loop over this dictionary file, the variable name should hopefully hint this. Yeah, giving us each line in the file. For line in this dictionary file, we get a line. What is line.rstrip? Does anyone know? Strips white space from the right side of the string. Right, so we're stripping the white space from the right-hand side of the string. Why am I doing that? New line characters, right. So some of you have looped over files before. When you loop over files, you get lines. The lines have new lines at the end. We're removing that new line to get a word. Our dictionary file looks like this. It's got a lot of words. We have new line characters at the end of each line. We're stripping those, getting the single word. This is checking if the length of the word is greater than 5. If that's true, and if the word is in reversed words. What is reversed words? It is up here. It is a dictionary. I think it's actually supposed to be a set. I think this code is buggy. We're going to find out. Reversed words.append, or reversible words. What is that? That's not reversed words. What is this one? So this is a list. Reversible words is a list. Reversed words is a set. Those variable names are unfortunately close to each other. If it is not in reversed words, which is a set, we append it to this reversible words list, and then we add it to this set in all cases there. Then at the end here, we say for word and reversible words, print word. What is this doing? What do you think this code might do? Getting palindromes. Yeah, I'm going to make this a little bit smaller. Can you still read that in the back? Yes, okay. So I'm going to run this, Python reverse. Dict object has no attribute out. I was right about that. This needs to be a set up here. This is not a dictionary. Nothing happened. Why did nothing happen? Reversed words up here is a set, yeah, that we are adding to. Is it checking for duplicates? Yeah, so this set here, if there are duplicate words, we're ignoring those duplicates. It didn't print anything out though. If there are, right, so there's a lot of things going on here. What are we not doing to these words that these variable names imply? Reversing them. So if there are no duplicates, which dictionaries typically don't have duplicates, then we've got a bug in our code. How do we fix this? This, by the way, is not on the website, or rather what I mean is this is on the website. There's a bug on the website. So we're live coding here at the moment. This is actually a bug. I didn't do this on purpose. This word here, to reverse it, this is a weird syntax, : -1. You'll just have to believe me, that does a thing that ends up reversing the word. This is one of the weirdest syntaxes in Python. We are slicing this string from nothing to the end of the string, so from the beginning to the end. -1, what does that do? Yeah, it's a step in reverse. Each character is going in reverse. So this reverses our string. We still don't have anything printed out. Yep. Right, so the original, the comparison happens here with reversed words. I'm appending the reverse to reversible words. This should be going on here. So that's a good point. We're actually not looking for palindromes here. What are these? Yes, words that if you flipped them, they are still a word. So lamina, the opposite of lamina is animal. So it's not a palindrome, it's like a copalindrome maybe. It's not a palindrome with itself, but another word. We are starting at lamina. Where is animal? Why is it not in here? Right, lamina we hadn't seen yet by the time we got to animal, because animal was first. So our algorithm here is a little bit faulty. It's faulty. We may fix that here. One way to fix it is we could split this code out into multiple for loops. So I'm going to do something here that is going to take up a lot more space. So we've got a set of all of the words over 5 letters. We have a list of all of the words that are reversible, and we're checking to see if the reverse is in that set. I'm going to paste in some new code here. I've got a comment here. It says store all of the long words. So we're doing similar to what we were doing before. For a line in this dictionary file, we're grabbing the word, checking if it's over 5 letters, and appending it. We have a list of every single 5-letter word. The next thing we do is loop over every single 5-letter word, reverse it, and stick it in this set. Same set that we had before, reversed words. The next thing we do down here is similar to what we had before, reversible words. It's an empty list. For word in words over 5 letters, which we constructed up here, this is this list of all the words over 5 letters, we're taking every 5-letter word, checking if it's in reversed words, and then appending it. So this algorithm here takes up a little bit more memory because we're making another list that contains all the 5-letter words in addition to that set. Oops, that's, yep.
Is the goal here just to get all of the words whose reverse is also a word?
Yes.
Then why don't you just ask if the reverse is in the original list?
Ask if the reverse is in the original list.
Yeah, so for word in whatever your name of your...
Yeah, we could do that. So why wouldn't we, why are you using a set instead of a list here? Any?
That's the thing. By using a set, it still does a hash look after. So it seems to me it would be just fine to go through each word.
Right. So
Set and then see if its reverse is in the original.
yes,
And if so, add it.
instead of reversing every single word, checking if it's then in that set, we could loop over all the 5-letter words, reverse it, and see if it's in the list. That will actually work. Why wouldn't I do that? Is there any reason? Or is that really the better way to do this? Yep. Yeah, so that's a little bit different. It would pick up the palindromes. Maybe we don't want it. Other guesses? If it wasn't a valid word to begin with. So the thing that, you're right, it would pick up the palindromes. We could avoid that by saying if it's also not a palindrome itself, right, if it's not equal. The reason I don't want to do it that way is if we have a very large dictionary file, this one's only megabytes, say it's a gigabyte. When we look for a word in a list, what does it do?
But I'm not saying you should look in the list. Your original list of words, this should be a set.
Our original list of words is a list here.
That's too bad. Make it a set.
I understand. So if we made it a set, the original list of words, if we made it a set, we can, you're right. At that point, we could reverse it and check to see if it's in the set, and then we've got a cheap lookup. So what I was getting at there was it's expensive to look up in a list. What's the problem with making it a set, a possible problem? We lose ordering. We could get ordering back by sorting it after the fact and then looping over it. So it depends on what we're optimizing for, whether it's memory, whether it is time. Here, we're optimizing a little bit more for time because sorting is an expensive operation, but we are not optimizing for memory because we're storing a list, a set, and another list. Now, I'm going to propose here we ignore memory optimizations for the moment because we're going to fix those in a little bit. I'm going to show you how to do that. Question? We could have. Yeah, so you're trying to cheat the system here. But we could have reversed each of them after the fact, stuck them to the end, reversed that list, and we would have the answer to this. We're going to not do things that way because I'm at the front of the room and I said so. There's not really a good reason beyond that, except that it dovetails into the next thing that I want to talk about here. So we have the answer here. We have animal, we have defer, we have the beginning of our list of words and the end, all of these reversed words and reversible words. What could I do with these chunks of code? With this loop here, what does this look like? Could this be made into a comprehension? Who thinks we could take this and copy-paste it into a comprehension as it is right now? Think, you know, we could copy-paste this. Would it close the file? Ah, so if this width here, if we left this in and did just this part, yeah, this part is what I'm asking you about. That's a good question. So this part here, who thinks we could take this for loop with the empty list and copy-paste it into a comprehension? Who thinks there might be a bit of a problem? You're not so sure if we can copy-paste it all the way. A couple people here. So I'm proposing there is a problem. What is the problem, a possible problem? Yeah, this line is not something we've dealt with before when copy-pasting. We've got a for, we've got an if, we have an append. We could fix this by removing this line and saying we're going to rstrip twice. We'll rstrip once here and once here. I don't like that so much. I don't like this because I find this less clear. Our algorithm here was pretty clear. We get the word, we rstrip, and we don't have to do it more than once, and we've solved our problem. If I'm not worrying about memory or time, I could take this and I could say, you know what, I'm going to actually split this into two for loops. I'm going to say I have one for loop of all of the words. We get all of the words, and then say words.append that word there. And then here, instead of looping over each line of the file, what can I do? For word and words, remove this. This here looks much more like it could be a comprehension. This here also kind of looks like it. We just have to put this inside that append. So we are wasting some space here because we now store every single word in a list, and then we store all the 5-letter words. We're going to ignore wasting space for the moment and copy-paste our way into comprehensions. So first thing I'd copy is words. What's the next thing I'm going to copy? Yeah, the thing we're appending. And then what? Then our for. All right, down here, same thing. We're copying this, and then what next? What are we appending? I think you all fell asleep all of a sudden. We're appending the word, and then we've got the for, and then we've got the if. So you're probably, I assume the reason you're not probably asleep but confused is why did we just go through all that effort when we had a perfectly fine for loop? We now have two comprehensions. We've got a whole extra list that has every word in the file. We could do what? And what do you mean by that? Substitute one list in the other. Ah, like this. Would that work? It does. I'm not a big fan of this. Why not? Yeah, it's not, well, yeah, if I formatted it more nicely, maybe this is better. Personally, I'm still not a fan of this. It doesn't fix our memory problem, and I really liked that variable named words. Not particularly attached to words per se, but I like that we had a variable. We do this action, then we do this action. So list comprehensions here, we're not really solving our problem with a list comprehension, but I'm going to show you the next step here is to make this into a generator expression. I'll talk about that in a moment. Before we do that, I want to do the one last thing here and make this into a comprehension as well. So we've got an empty list. We're appending our word. Then what are we doing next? I think you're all sick of copy-pasting at this point. We've got our for, and then we have our if. So we have a break in a few minutes. Before we do that break, I'm going to show you one thing that we're going to come back to. So the thing I'm going to show you here is the reason we are getting to all of this, the reason I'm kind of seemingly wasting our time here by making a comprehension and then another comprehension that loops over the original list when we had a perfectly good for loop. When you have a list comprehension, and what does a list comprehension give you? A list. The type of this thing is a list. When you have a list comprehension, you loop over it just one time. You don't actually need a list. Not necessarily. What else could you deal with if you're looping over it one time? What else can you loop over in a loop? An iterable. A set, a list, what else can you loop over it? A generator, a dictionary, a string. Anything that you can iterate over, you are able to iterate over, is an iterable. Anything you can iterate over is an iterable. So we just need an iterable. I'm going to show you this in a moment. If we change these square brackets to parentheses, what do I get? Yeah, so what do we normally get if we take square brackets and turn to parentheses with a list? A tuple. This is not a tuple. Somewhat counterintuitively, this is not a tuple. This is a generator. So if we have numbers is 1, 2, 3, 4, and I say n squared for n in numbers, the type of this thing is list. The type of this thing is not tuple. What is it? For those who've seen it, yeah, this is a generator object. We are going to talk about these generator objects. So we're going to take a break here in a moment. I'm probably going to go a few minutes after the break, and we'll just kind of shift it slightly. The food is out there. There are probably people already lined up. I'm sorry we didn't take it early. This is my fault. G equals this generator here. We have a generator. What is the first thing in this generator? For those who haven't seen generators before, what's your guess that this might give us if numbers here is 1, 2, 3, 4. What do you think G of 0 might be? 1. It's not 1. It's an error. What is the len of G? What's the length of G? You didn't want to guess this time. It is not 4, you're right. It is also an error. Why do generators act in ways that we don't like? Why don't they act like lists do? Right, so the one thing we can do with a generator is iterate over it with a loop, with a list comprehension, with anything that will loop over it. So if I say for x in G, what do you think is going to print out? 1, 2, 3, 4? 1, 4, 9, 16. Yeah, so the generator here was n squared for n in numbers. Our numbers are 1, 2, 3, 4. We print out 1, 4, 9, 16. So generators are like list comprehensions, but they don't take up the memory of a list. They are lazy iterables. They are a promise that at some point in the future, if you start looping over me, I'm going to give you items back. So if I loop over this, if I say for x in G, for x in G, we're printing out x, what am I going to get here when I print out of this? Let's say I say print x plus 1.
Is it exhausted now or no?
Yeah, so I'm not going to get anything?
You've already used your generator.
Yeah, so for those of you who've seen generators before, you already know the answers. I should have asked you not to say the answers, but you are correct. It is exhausted. It's empty. This is very unlike a list. What happens when you loop over a list twice? You get things back twice. You can loop over a list as many times as you want. You loop over a generator twice, you get nothing back the second time. It is exhausted. So generators, they are strange in that they exhaust themselves. Why am I using a generator here? Save memory. We have a list of all of these words. This is not a list of words. This is a promise that when you loop over this thing, there's a file that we're going to loop over it, give you back the R-stripped, the stripped version of the lines at the end to get the words, and then we're going to do something with those in that list comprehension. Okay, we're going to continue taking a look at generators after the break. We're going to take a break now. It is 3:02, so we're a couple minutes into the break. Snacks are down the hall. I should already know this because I was here in the morning. They're down the hall, wherever the end of the hall is. I don't know. Just follow the people who know where they're going. You'll find where the snacks are. There's food. There are drinks. Be back here in 30 minutes. So if you can be back here at 3:30 or just after 3:30, that would be wonderful. We're going to start back up. If you have any questions during the break, feel free to chat with me about anything or any of the TAs. All right, so I said that we were going to go for 30 minutes. It's supposed to be 20 minutes. So those of you who showed up in 20 minutes here, you're going to get some extra time to work through exercises. Those who came at the correct time, it's my fault that they missed out on something. Or not the correct time, the time that I said, the incorrect time. So we're going to jump into some exercises here. Before we jump into exercises, I want to show you a couple things. So the things I'm going to show you here that we're going to review in probably just a moment as more folks come back in here. N squared for n in numbers. What is this thing I just made? A generator. And I made it using not a generator comprehension. What is this called? Generator expression. Why isn't it called a generator comprehension? Yeah, that's an unknowable piece of information. Maybe it's knowable, I don't know. There might be a Python mailing list somewhere that says why they chose this name. List comprehensions came first, generator expressions came later. Why they chose the name generator expressions, I don't know. We have other types of comprehensions. Generators don't have their own. They have an expression. If you call it a generator comprehension, I'll know what you mean. Everyone else will know what you mean. And probably no one will care except those pedantic people who correct you and say, actually, it's called a generator expression. You're welcome to call it a generator comprehension. Everyone will know what you mean. So it's called a generator expression. Technically, it is called a generator expression. You're welcome to call it a generator comprehension if you'd like to think of it that way, because it really works that way. So you might want to leave the door open actually, because there might be people who are supposed to still come back in. I see some empty seats still, because I did start a few minutes before I said I would. How do I get the first item from a generator? Does anyone know? Yeah, so in Python 2, it was .next. That does not work in Python 3. Yeah, so in Python 2, it actually was, this works in both 2 and 3 next. The thing that this does differently in 3 is it calls this under the hood. What are dunder methods? Methods with these double underscore something double underscore. Dunder, what are dunder methods or magic methods? So I'm calling this a dunder method because it's double underscore something double underscore. What do these do? Yeah, so they add some functionality that Python understands. So dunder len is what gets called when we call the len function. Dunder add is what gets called when we use the plus operator. So this is kind of operator overloading or overloading some functionality that Python understands. The functionality we're overloading is the ability to get the next item from something. This is something iterators have. I am not going to talk about iterators because that's another topic. Iterators, though, are what generators actually are. Generators under the hood are implementing something called the iterator protocol. You can look it up on your own. I've given a talk on it. There's a blog post on it. There's resources on the internet for looking up what an iterator is. A generator is a form of an iterator. An iterator is a lazy thing. It is a lazy iterable. Generators are lazy iterables. So the thing we care about generators is that they're lazy iterables. Technically, that means they're also an iterator, which means we can use next on them. Never type this. Instead of typing this, I want you to type this. No dunder next, only use this next built in. The reason I say that is under the hood, Python is doing the double underscore next for you. This is the high level version. Under the hood, it happens to be implemented oftentimes as that dunder next. You shouldn't rely on that though. You should rely on this next function. So this is how to get the next item. Notice it is giving us the next item. It's stateful here. What's going to happen here? An exception of some port, possibly. So when it is empty, when we're at the end of our generator, we get a stop iteration exception. And we get that forever because we're empty at this point. So we can only loop over our generator once. If we want to loop over it manually, we can use next. If we want to loop over it not manually, we could use a for loop. They do the same thing there. Questions? Yep. Yep. What you're saying is an iterator. So iterators, implementation detail here, sort of. Every iterable under the hood uses an iterator to be able to be looped over. So actually, everything you ever loop over, an iterator is involved in some way. That's how for loops actually work in Python. You're saying, I'm assuming that iterators in general use something more elegant than a try-catch using stop iteration. That is actually not the case, or rather it's not the case for iterators in general. At the C layer, there are sometimes shortcuts that are used for things like lists, for common iterators, but for iterators in general, the way a for loop works under the hood, if you say for n in squares, it actually has a try except in there that is manually loop over this thing using next. If it gets stop iteration, it stops. Exceptions in Python are not necessarily for errors. They're not even necessarily for exceptional cases. A for loop ending is not a very exceptional case. It's something that happens for every for loop, probably. So stop iteration is actually what's being used under the hood with an iterator. So some iterator details, a little aside there. You don't have to understand anything I just said, but feel free to ask me questions about iterators afterward. So generators, we can use next on generators to loop over them manually. There's a couple tools that you can use with any iterable in Python. One of these is min. What does min give us? Yeah, the lowest number, the minimum number. And max gives us the maximum number, which in this case, you're right, happened to be the first number and the last number of this list. If they were shuffled up, it would give us the minimum and the maximum. It accepts any iterable. You can pass a generator to it. All. Does anyone know what all does? Yeah, so it tells you if everything satisfies a condition. It actually works on this. So what all does is it loops over the iterable that we give it. It checks to see if everything in that iterable is truthy, meaning it evaluates to true if you convert it to a Boolean. What could I add here that would make this be false? An empty string. Or none. I heard someone say that. What else? False. Lots of things are falsy in Python. 0, an empty dictionary. Anything that is seen as empty or 0, if it is falsy, all will give you false back. If any one of those is falsy, if all of them are truthy, it gives you true. So any and all, any is not quite the same as this. What does any do? Yeah, so if we make this false, still gives us true. If I make this an empty string, it's still true. If I make this 0, it is now finally false. All of these are falsy. If any one of them is true, it is true. So any and all, these were special purpose made for use with generator expressions. All, n greater than 1 for n in numbers, is false. Why is that false? What is numbers? Yeah, it's got 1, 2, 3, 4. 1 is not greater than 1. Any of these greater than 1. What is that? True. That is true. So any and all, these are special purpose meant for generator expressions. So I want you to know about any and all. For those who came in on time, you were not late. I started early. Min and max, these are on the website. And the other thing that I showed was if we have squares being a generator, we can use next to manually loop over it for n in numbers. If I say next squares, we get each of these individually. So a cool thing with next is you can get the first item from a generator without even writing a loop. You use next to get the first item. Then you can loop over it after that point. That's a very common use of next that you'll see. Grab just the first one and then maybe loop and compare to that first one, for example. All right, so you've got any, you've got all, you've got min, max, and next. I want to show you something before we jump into the exercises. The thing that I'd like to show you here is if we have code that looks like this. Numbers is some list of numbers. We'll say it's the same list that we had before. For n in numbers, if n is greater than 1, then I would like to break. Before I break, though, I would like to say condition equals false, and this will be true. What is this equivalent to? Yeah, so this is a little bit tricky. I'm going to propose that you can actually take code that looks like this and copy paste it into an any all generator expression situation. So unlike list comprehensions, you can't quite take a loop that is sort of in a generic way, empty list, building up a new list and copy paste it. You've got to have code that is in this format, if, and then a break based on a condition. This often can be made into this condition if any, and then what is the looping part of this any? The looping part specifically. So we're going to have something here for what? For n in numbers. Now, what is the condition? Yeah, so if n greater than 1, this is the thing that normally goes at the end of our comprehension. I'm going to put this at the beginning and remove the if. I'm making a bunch of true-false values. N greater than 1 for n in numbers, each of these gets a true or a false. This generator does no work, though. So this generator here does no work at all until we pass it to any, and any's going to loop over it. Once it finds one that is true, it immediately returns true. It short circuits just like this break here. Yep?
You don't need the inner parentheses,
I do not. Yeah, I was going to talk about that in just a moment here. So this any, no worries. So this any here, I actually, when I have a generator expression that is the sole thing inside a set of parentheses, I can remove those parentheses. So this should be an indicator here that the Python core developers really expected you to take generator expressions and pass them into functions. Pass them straight away into a function, because if you've got extra parentheses around them, you can remove those extra parentheses. We have a single set of parentheses. It represents both the function call and the generator expression. I could have this. What would this be? A list comprehension. If I make those into parentheses, that's a generator expression. Because I have two sets of parentheses that are solely the only thing inside of a function call, I can remove those extra parentheses. The Python core developers actually allowed us to do that. Questions? About any, all, anything else? Yep.
So if you don't have, we're taking those off, is it always going to assume that it's a generator expression?
Yes, yeah, so this here is always seen as a generator expression. However, this is a good question here, because if we, for example, had any and we passed something else to it, maybe any took another function, it was do something, and do something took the number 4. It is not possible for me to remove these parentheses. Why not? Yeah, where does it end? There's no, the generator expression needs an end there. There's no parenthesis to end it. So this might be sort of a tuple or something. There's a comma here. It's kind of ambiguous. So they only allow you to remove the extra parentheses if it's the only thing in those parentheses. But it always sees that as a generator expression. It's never going to mix that up and think it's a list comprehension. So if you see a list comprehension, but there's no brackets around it, it's a generator expression that's being passed into a function. Other questions? Yep. Right, yeah, so that if you're using a generator expression instead of a list comprehension, and you're looping over that generator expression, it is more memory efficient because the generator itself doesn't store the items as it goes. It gives you an item. From its perspective, that item is gone and never even existed. Yeah, so where does it store them? It doesn't store them, but that doesn't really answer your question. It doesn't store them where it gets the numbers from, because it has to compute them as it goes, it computes them from the iterable and from this bit of code. This bit of code, n greater than 1, this is our recipe for the thing that the operation we're going to do for each of the items as we loop over this thing. So we could actually, if we wanted to get tricky here, we could play with these and do some odd stuff just to see how they work. We could say, we've got numbers, and we're going to take squares and get the next item. Before I do that, though, I'm going to say numbers.insert 0 to item 0. I just changed numbers before I started looping over squares. What do you think this is going to do? What is your guess? What could it do? What are the options? Could return 0. What else could it do? Could return 1. Other options. Could throw an error. It could say, I had something I'm about to loop over, and I know that you changed that. I did not like that. I'm going to give you an error. What they chose to do is to give you 0. So this is an implementation detail of the thing we're looping over. The thing we're looping over here is this list. It keeps track of, in its iterators we're looping over it here, as the generator is looping over it, it keeps track by its index. So if we actually said here, numbers, index 1 equals 9, when we do next again, we get 81. If we said numbers, and we're going to delete the next number, so we will pop off, actually I'll just delete index, what index are we at? 0, 1, 2. So our numbers here is this. If we get the next one now, it's 9. So this isn't something you should ever do. Don't change the underlying thing you're looping over as you're looping. It's a bad idea. Sometimes it gives you an error. Sometimes it gives you an unexpected thing. Sometimes it gives you what you were expecting, maybe if you expected this behavior. But this is what generators do. Generators are lazy. And so because they're lazy, you've got to be careful with them when you're using them. You've got to make sure you loop over them all the way, and you don't change anything as you're looping over them, for example, under the hood. All right, we have some exercises here. So the exercises we're at are generator expressions on the website, generator expression exercises. And I'm going to give you not too much time on these ones. I'll give you about 15 minutes here. And we'll probably solve one of these together. That first one there is a hint. You probably want to use any or all. If you can't figure out the first one, feel free to skip to the next one. For all of these, there's a generator expression that you should probably using somewhere in your code. And some of the tests will actually complain at you specifically if you're not using a generator expression. So any questions at all, put up a red sticky. The TAs are in the back of the room, and they are here to help. They need work. They're sitting down because none of them are sitting down. It's just Eric that's sitting down. They need work, so put up a red sticky if you have any questions at all about anything, whether it's generator expressions or something else. You may stump some of them because they haven't seen the exercises yet. I'm the one that knows the answers to the exercises, but that means you get a rubber duck at least. You can talk to them. They will be your rubber duck and happily nod their head and say, I don't know the answer either, but I'd like you to explain what your thought process is here. So work through the exercises, put up a red sticky if you have any questions at all, and I am here to help. So I know many of you are new to Python. If you haven't seen this before, there is a thing called range. Range gives you all of the numbers up to a given number. So we have range here. If we looped over it, we would get a list of all the numbers from 0 up until just before 50. So if you are looking for all the numbers up to and including 50, you put a 1 there, and if you wanted the range to start at a different number, you can actually give it a different number to start at, for example, 1. So something to probably use there in that first exercise. You're looking for primes. You're going to want to loop over a range of numbers. Any questions at all? Put up a red sticky. So the way it improves it is, so how you normally do it with a prime number is you'd say, let's loop over all the possible factors, see if it is a factor. If it is, then that means it's not prime, so return false, otherwise return true. The early break is the thing that they can turn into an any or an all. So they can say for all of the possible factors, if it's a factor, the condition to see if it is divisible, if all of them are not divisible, then it is prime.
Oh, so you're not thinking that they would generate like a list of the factors first?
Not a list of them, but a generator of the possible factors. The possible factors, and then they use any or all to and the condition for any or all is going to be whether it's a factor.
So the solution I had immediately thought, and also with this person, Trey Hunner, is
Yep.
was just a list for a for loop that started at 1 or 2, I guess.
Yep. Yep.
And then just went up to square root of the number.
Yep.
And as soon as it finds condition, that means it's composite breaks.
Yep.
Or returns false.
Yes. Yep.
But that doesn't even require the generator.
It doesn't. You're right.
It's just that.
Just as efficient? Yes, it is just as efficient. It is not more efficient per se,
Right.
because the any and all actually do break as
Yeah.
well. Yeah, so this first one we're going to do together for that reason, because the usage for any and all is the tricky part, because you can, whenever you've got an early return, or whenever you've got if something, return true, otherwise return false, that's basically the recipe for any or all.
Like the memory intensive way of doing this is you have a list comprehension,
Yep.
and then you have like a remainder like does this equally to that, and then you can call any on that. Or yeah.
Yes.
Any
Yep.
on that.
Yep.
But then you could replace that list comprehension with a generator.
Right, and it's not just the memory intensive way, it's the memory intensive way and the slow way,
Yes, yeah.
because it's not going to break. Whereas any and all break, which is what makes it just as efficient CPU-wise. The generated expression is just as efficient memory-wise because it doesn't actually store them.
But presumably just the normal for loop.
Yep.
And the break if it's composite. Like that. And that's perfectly fine in that kind of
Yeah.
optimized.
Well, it can't be optimized except by using I mean, we're not talking about optimization so much as talking about rewriting the code, because the list comprehension isn't about optimization so much,
Right.
because the append, it is a function call, but the more expensive part of the append is the method will come, numbers.append. And so if you can actually say append equals numbers.append and then call append each time the for loop, which is silly, but like it's an optimization, and it's about as fast as a comprehend. And so you're right, it's like, in terms of optimization, it's not an optimization so much as it's a readability thing. Because any and all, it's just another way to write your code. Yes. right, we're going to solve this first one together here. So I've actually already solved it. I've sort of cheated here and solved it while you weren't looking. Some of you were looking, but many of you were working through the exercises. For n in range from 2 up to our number, this could be optimized. We could say up to the square root of the number, but I'm not going to do that. If the number in divides evenly the number that was given to our function, then we return false, because we know it has a divisor, which means it's not prime. Otherwise, we return true. Where's the generator in this solution? There isn't a generator. Did anyone figure out how to make this into using a generator in any way? Yep. Yeah, so this here, there is a blog post I wrote on this. If you search for checking a condition while looping in Python, that's probably not the name of the blog post. I don't remember what it is. You'll find it in Google somewhere there. It basically tells you if you have a for loop with this syntax here, you've got for if we return true, otherwise we return false. Whenever you've got this early break to get one thing, otherwise you go to the end, you get the other thing. This here is the recipe. This is the start of a recipe for making an any or an all generator expression. So if I'm going to copy paste this into a generator expression, I would say return all, and I can do the same thing with any. I'm going to do all though. What is the condition in human English that I would check for all of these numbers that would let me know whether it's prime? What do all these numbers have to meet this condition? They don't evenly divide. What is our condition here? They do evenly divide. So I'm going to take this condition and invert it. If they don't evenly divide, if all of them don't evenly divide, then it is prime. We're going to do the same thing with any. You can do the same thing with any. Whenever you can use all, you can actually use any. So return any. I'm going to reverse this condition. If any of these evenly divide, what do I know about this number? It is not prime. So what do I need to do to this line of code? Yeah, I need to negate it. Return not any of these evenly divides. So not any, flipping the condition, is the same as all. Or all, negating all, flipping the condition from the any, those are the same here. So you can write these in either fashion. Personally, I prefer all because I think it's a little bit easier than this not any situation, but whatever works in your mind will work for this. So whenever you have something that looks like this, for something, if something, early break, false or true, early break, true or false, the opposite, you can make it either any or all. Questions? So this one was tricky. I did not expect you to necessarily get this one. I wanted you to try to struggle at it. I want to work through one together that you probably didn't do. Who did translate? All right, no one did translate. Wonderful. So translate is supposed to take a sentence that is in Spanish? Which way did I do it? Yeah, it's supposed to take a sentence in Spanish and translate it to English. This is not how translation works, by the way. This is more like transliteration. We're taking words and we're taking the literal meaning of that word into another language. Notice, even in this particular case, we have la and el. One language can have two words for the same thing, that another language only has one that represent that thing. So this is not translation, this is transliteration, but it's a silly example. So we have a sentence that is supposed to be in Spanish here, or simplified Spanish. We're supposed to return not a Spanish sentence, but an English sentence. So our tests fail. Well, they fail if I was running the right one. Translate. What do we need to do? If we were not using comprehensions or generator expressions here, how would we take this sentence and take this dictionary here and translate it from Spanish to English? Yeah, so take each word in the sentence, run it through this dictionary somehow. So I need to make an English sentence first. So I'm going to return that English sentence. This English sentence, I need to build this up somehow. So I need to say, for word in Spanish sentence, is this going to work? What do we get when we loop over a string? Characters. Strings, but strings representing the characters. So we get the individual characters as strings. So this isn't going to work. How can I get individual words from this sentence instead of... Yeah, so I need to split this up based on spaces. So for word in Spanish sentence dot split, what could I do with this word now to get the English equivalent? Yeah, so we have a dictionary called words. It does. We are looking for, I hope, yeah, Spanish English. So we have a Spanish sentence. We've got a Spanish word here. We can say words, give it the Spanish word. It should give us the English word. What can we do with this? Add it to the list, so we could say English sentence plus equals this. Is that going to work? Why does this not work? I see you shaking heads. I need a space. Where do I put the space? After it? Yeah, this is a pain because our tests don't pass. The reason they don't pass is we've got the cat space, which is not the same as the cat. We then have to trim the space. How can I avoid this situation? Strip? Yeah, I could do R strip. It works. Any other way I could do this? Put them into a list and then join it with a space. All right, so instead of a string here, I'll make a list. So instead of concatenating with that plus equals, what am I going to do? Append. I probably should have called this words instead of sentence. And then what do I do with this English words list at the end here? Join, like this. Yeah, we wish this worked. It doesn't work. It doesn't work in Python because lists don't have a join. We have to do it a little bit backwards. Ask the join, the space, to kindly use itself as a delimiter, joining together each of the words in this list. Things are a little bit backwards in Python. The reason for this is, what is the reason for this? Anyone know? What does join accept? What type of thing? A list? A string? An iterable? Yeah, it accepts anything you can iterate over. Instead of saying everything that you can iterate over needs a join method, or lists have a join method, if you don't have a list, you're out of luck. We said strings have a join method. They accept any iterable. So it's backwards, but there's a good reason for it to be backwards here. So we're joining together by space each of these words, and that does pass our tests.
Then just a lot easier to add it like space plus Spanish.
Yeah, then there'd be one at the start, and I'd have to strip it from the beginning. So I'd still have the same problem with that space. But yeah, so this join here, the reason join is so useful is because we have this issue of when we're trying to stick things between other things, we don't know when we're at the end or the beginning with a loop in Python. We've got to use enumerate or something else. So join here, we're making a whole list just to make it into a string. What does this look like that I could change this code to? A list comprehension. I've got an empty list. What do I copy paste next? Yeah, this weird thing that we're appending. Words, look up Spanish word. Then what? Then R4. So this is equivalent. Anything else I could do? Yeah, I could just get rid of the variable. Cool. Are we done? Add parentheses? Like this? Outside. Out here? Yeah, so here, this is optional here. The reason this is optional, so the parentheses here, we need those when we're doing stuff over multiple lines. Why doesn't Python require those in this case? So we're in a return statement here. we've got open brackets. In fact, we also have open parentheses. So as long as we have some kind of open bracket, parenthesis, brace, Python allows us to break over multiple lines of code, which is handy. Anything else I could do with this code? Get rid of the brackets. How many times are we looping over this list? Once. If we have a list comprehension, we're just looping over it once, what can we do? Make it into a generative expression, yeah. Can I get rid of those parentheses? Yeah, in this case I can, because I've got 2 extra redundant parentheses there. So this is actually a really common use of generative expressions, is inside something like a join method, where you've got something you're joining together. You don't want to make a whole list of those things. Lazily, just figure out what the things are as you're looping. Now notice this code isn't something I could write using a for loop. There's no equivalent to this, because the equivalent of something that doesn't build up a whole list, that is actually lazy and memory efficient, is using plus, is using concatenation. There's not a join equivalent to this. So this allows us to write our code in a fundamentally different way. Because we're using a generator expression, we're able to use the join method here and still be lazy with our code, still not build up a whole list. Questions? Who has written a generator expression before this tutorial? So these are new to a lot of you. I don't expect you to understand these immediately. These are something I want you to be aware of and to think about where you might be able to use them. In general, use list comprehensions. Try to identify places you could use list comprehensions, excuses to use them even if it doesn't make sense. If it seems like it doesn't make sense so much, but you can use it, if you realize, I'm only looping over this list once, I could turn this into a generative expression. That's the point where you can say, my code's actually going to be fairly memory efficient, and I'm going to use this syntax here that is like a list comprehension, but is not making an entire list. So it's difficult to recognize excuses to use these. We'll talk about that in a little bit. Before I do talk about that, I want to show you a couple other types of comprehensions real quick. One of these comprehensions is a set comprehension. So in Python, we're going to go here. What was my code called? I think it was reverse. So reverse.py, notice I'm making not an empty list, but an empty set. What does add do with a set? It adds it in. Why isn't it append? Yeah, sets aren't ordered. Because sets don't have an order, there's no notion of the end. Append adds to the end of a list, add adds to the set because it's a distinct, unordered grouping. So we've got an empty set. We loop over something. We build up this set as we're going, just like we build up a list. I can take this here and say I'm going to take this set, and I'm going to copy the first thing here, and then I'm going to copy this thing here, just like I'm making a list comprehension. What is this that I just made? What is this thing called, do you think? A set comprehension? That is a great guess. It is not the correct guess, but it's what I expected you to guess. You all fell for my trap. It is not a set comprehension. What is this? We've actually seen this already. A generator expression. Why is this a generator expression? Which part of this is the generator expression? Or which part of this isn't? Yeah, so set is a function. What does set accept? Any iterable. If I pass it 1, 2, 1, 3, I get back 1, 2, 3. They happen to be in order this time, but who knows, they might not be. So set accepts an iterable. What's the iterable we're passing it? What type of thing is it? A generator, because we passed it a generator expression. So this is not a set comprehension, just like this is not a tuple comprehension, but it looks like one. You can make a generator expression, pass it to tuple. It looks sort of like a tuple comprehension. You could think of it that way if you'd like, but it's a generator expression passed to tuple. Yep. So if we do set like this,
Yeah.
yes, so the reason it throws an error is this is not an iterable, it's 4 different arguments. So list actually also throws an error. If we want to take a list and make a list 1, 2, 3, 4, the best way to do it is like this. Another way to do it, though, if we had a tuple, for example, of items, or a list or a set or anything else, if we pass it to the list constructor, it loops over this iterable, gives us back a list. So set here, we actually need something to pass to it, whether it's a tuple or a list or something else. Does that answer your question there? That we had 4 distinct arguments the other way we did it.
But in that case, why, so generally we just remove that extra parentheses, and this why is it?
Yeah, the reason here is this actually isn't a generator. What is this? Does anyone know the type of this thing? It's a tuple. So this is something that if you're new to Python, this is a little bit weird. We not only have lists in Python, we also have tuples. Lists we can change. They're mutable. Tuples are immutable. They're sort of like immutable lists. There's other reasons we use tuples, but those parentheses, this is confusing because generated expressions use parentheses, tuples use parentheses. This is a tuple, whereas this up here, those extra parentheses we had, that does not make a tuple. This is another one of those places that I failed to fool you earlier so much, but I often fool people by showing what looks like a tuple comprehension. It is actually a generator expression there. Yep. A tuple, what looks like a tuple comprehension instead of a list, or what looks, why would you use a tuple over a list? Yeah, so a set sets and lists and tuples are very different things. Sets don't have duplicates and they aren't ordered. Tuples are ordered and they're essentially just like lists except you can't change them. So tuples compared to lists, I can't easily explain why you use a tuple over a list. There's some convention reasons there. Typically you wouldn't do this. Usually I would recommend not doing this. What would I do instead of this? Yeah, so this here is a generator expression passed to the list constructor. I can just use a list comprehension in that case. There is no such thing as a tuple comprehension, so you have to make a generator expression, pass it to tuple. Now this here, I want to show you this because this is not actually the way you make a set comprehension. Does anyone know how to make a set comprehension? Yes. Yeah, so I answered your question by asking another question. That's how we make a set comprehension. If you're in Python 2.5 or so, you actually don't have this syntax. If you're in Python 2.5 though, I'm sorry. That's old. Python 3's been out for a while now. You're probably on an old Red Hat Linux enterprise system, and there's not much you can do at that point, but set comprehensions have existed for quite a while, so you don't have to worry about the syntax. This exists in all modern versions of Python, really. So one more thing I want to show you. If you don't use sets much, one thing I'm pretty sure you all use at some point, or you will be using if you're new to Python at least, is a dictionary. So if I make this here, we have from string import ASCII lowercase, this letters thing here. What does this code do? What is your guess? Oops. I have Python 3.7 installed. That's fun. What is this code going to do? So it makes a dictionary. What's in the dictionary? Key value pairs. What are those key value pairs? A letter and a number. Yeah, so the letter is the key, and the number corresponding in the alphabet is the value. So A is 1, Z is 26. These are in order because I am in Python 3.6, which happens to have ordered dictionaries as an implementation detail. They are guaranteed in 3.7. All right, so I am making an empty dictionary, looping over it, building up the dictionary. What is your guess that I could use here? Could I use a list comprehension? A set comprehension? A dict comprehension? So there is something that you will see occasionally letters equals dict. Does anyone know what the dict constructor accepts? Pairs, a list of tuples. Yeah, something like a list of tuples. So I can give it, for example, 2, 3, 4, 5. The keys are 2 and 4. The values corresponding are 3 and 5. So a list of tuples accepts something like that. So I could say here, what would my key value pairs be in this generator expression? Yeah, letter, and then n plus 1. And I need to put parentheses around there to actually make it valid syntax, because it gets confused if you don't have those. And that works. This is not a dictionary comprehension. This is still a generator expression inside the dict constructor. There is syntax for a dictionary comprehension built into, I think, Python 2.6 or so. It looks like this. This is still not a dictionary comprehension. I'm not quite there. What is this? It's a set comprehension. What do I need to, what distinguishes a set from a dictionary normally? Colons. Yeah, you've got a key and a value. Sets are kind of like a dictionary without the value. Dictionaries have that value. So letter, colon, n plus 1. This is a dictionary comprehension. These are things that I write a lot in my code. I am frequently building up dictionaries from something else, which means I have opportunities to use dictionary comprehensions. Questions? Yep. They are. It's not the constructor that's slower, it's the function call. Because this is calling a function here, and a function under the hood is going to have a little bit of stuff that goes on that has to do with the calling of that function. However, this is only one function call. It's not like it's calling a new function every time. It's looping. The generator expressions have a little bit of overhead. If you had a list constructor, you passed a generator expression to it, it's slow not just because of the call to list, but also because working with a generator is a little bit of overhead there. That's not the reason I would use this, though. The reason I would use this is the syntax exists for you to use. Question? Yeah. Thank you for asking that. That's up at the top here. From string, I imported ASCII lowercase. Yeah, that is on the website. All right, we have some exercises here. A couple more questions. Yep. When are comprehensions not as efficient as like a for loop? So comprehensions, generator expressions, for example, that return true, return false that we had before, that may be faster than the equivalent generator expression with an any or an all. Not by an order of magnitude, but because there's a little bit of overhead for the generator itself. That overhead is pretty minimal, though. If you time that code, you are probably not going to notice a difference. It's probably fairly negligible. If there is a difference, you can look it up on Stack Overflow or try it out yourself and prove me otherwise. But usually the difference is fairly small. So I don't have a great answer for that question, because usually since they are a special syntax, there's usually not much opportunity for them to be slower. So exercises here, we are at set comprehensions and dictionary comprehensions. You know what? Before we do these exercises, I'm actually going to ask, because we only have 20 minutes left, I think I know your answer, and it's never quite the answer that I'm looking for when I'm teaching. But I'm going to ask you anyway, instead of assuming. I'm going to see what you actually want here. Who would like me to skip this exercise section and get a little bit more material in? Because we have a little bit more material on the website than we're actually going to get through. We're not going to have the opportunity for our last exercise break in either case. Who would like me to write code? And you won't get much opportunity to actually write code yourself at the end here. You won't have another exercise section. Who would prefer that? I keep going. Okay. Who would like to do exercises? You want to work through these yourself? There are no hands. So as a teacher, this is a situation that always frustrates me, because I know that the opportunity for you to learn the best is to do this thing, to actually apply the knowledge that you have just learned. You haven't learned it yet, you've seen it, to actually attempt to take that knowledge out of your head and apply it. However, I know also as a teacher that no one wants to do that in the moment. You want to learn the next thing instead of applying the current thing. So what we are going to do is I am going to appease your desires here, since there wasn't even one person in the room who wanted what I wanted you to pick, and we're going to go to the next set of material here. I would encourage you, though, I'm compromising with you here, try to work through these exercises after this tutorial is done. And if you get stuck on them, send me an email, or ask someone else who's in the hall, say you're working through exercises for a tutorial. Try to work through these on your own, because I made these exercises for a reason. There's about 30 exercises on the website. You definitely have not worked through them all today. You couldn't work through them all today if you tried to. I want you to work through these on your own, even though you're not going to do them in the room with me here. You may notice there are answers on the website, or rather there aren't answers on the website. Who has clicked on the exercise answers page? You were looking at the answers. You haven't even done the exercises yet. That was a trick. You could have looked at the answers for earlier exercises. You didn't get the opportunity to do so. You didn't get the opportunity to do so because there aren't answers on the website currently. I don't have answers for all of the exercises worked out yet because I want some extra explanations I tend to do, and some of this material is a little bit new that I've thrown in here. So if you give me your email address on the exercise answers page when you eventually go there, for those of you who haven't tried to cheat and gone there yet, you can get the answers. Once I send them out, I'll send them out over email. If you put your email in a few months from now, I'll just send them out immediately, because people do sometimes watch the PyCon tutorial videos, as some folks, I guess, at home will be doing. This is kind of meta to be referencing the people on YouTube watching this, if they are on YouTube. You can put in your email there right after this tutorial's over or in the future and get those answers. Do feel free to send me an email if you have questions about these exercises that you're not about to do after you leave the room. We're going to move to the next section of material. Any questions before we kind of do some new stuff here, since we're not doing exercises? Where the tutorial? So the videos will be posted on YouTube under, I think, a PyCon 2018 YouTube channel. They often go up within 24 hours of them being done. Yeah, they go up super fast. The tutorials sometimes are not as fast, but I have no idea. You'll find out within the next week here if this is online. But yeah, those will be on YouTube. I think they'll be sent out over email as well, but you'll see people tweeting about them. You'll probably get an email, but they will be on YouTube. What can you use comprehensions for? Set comprehensions, dictionary comprehensions, list comprehensions, generated expressions. What can you use these things for? Transforming lists, yeah, so taking one list, making it into a new list. What else? Is there any other case you can use these? Data generation, yeah, so generated expressions, they don't take a list and make a new list out of it. They take a list and make a lazy iterable that you can later loop over and get some work done. So they're kind of delaying work, which is interesting there. Generator functions, which I'll show you in just a moment here, are kind of the general version of a generator expression. Just as a for loop building up a list is the general version of a list comprehension. So set comprehensions are for taking an iterable, making a new set out of it. List comprehensions are for, again, taking an iterable, making a new list out of it. It could be a list, it could be a string, could be a dictionary, it could be anything. Dictionary comprehensions, again, for looping over something, some kind of iterable, and making a new dictionary out of it. When shouldn't you use a comprehension? It's sort of a trick question here, yep. Yeah, if you're not trying to make a new list, a new set, a new dictionary, don't use a comprehension. If you're not doing the thing that we just said that they're for, don't use one. A little bit circular. Yeah, so if you need a side effect while you're doing it, it depends on who you ask whether you should do it. So for example, numbers. We have numbers. If I said first n is maybe a list comprehension where I say numbers dot pop for I in range n. What is this doing if we had a variable n there? What does pop do? Yeah, it's removing the last thing from numbers what would this list have in it? Nothing? Yeah, what does pop return? Does it return anything? So the default return value for a function is what in Python? Not -1, but that's a good guess. Which function? Yeah, the default return value for any function in Python. Any function, if you write a function, what's the return value? It's none. Default return value is none. Pop doesn't return none. It returns the number it pops. So it not only gives us something back, it also changes something, which is not a common thing to see in Python, but you do see it. It's mutating something while returning. So if we pass in 2, we get the first 2 of these, and we removed them. We removed the first 2, or sorry, not the first 2, the last 2. We removed the last 2, and we got those last 2 back in the opposite order. So this is a list comprehension that does have a side effect. Is this good? Is this bad? Good when you want it to be good, yeah. So if you want this behavior, you expect it, this is maybe not a bad idea. If you don't like the idea of a side effect while you're building up a new list in a list comprehension, you don't want to use this. So this is up to you. This is a tool. Whether you have a side effect is up to you. I do want to show you a side effect you should never have in a comprehension. What is this going to print? What is your guess? What does range start at? 0. What does it end at? The number just before the one we passed to it. So what do you think this will print? 0, 1, 2, 3, 4? Plus a bonus list. Where did that list come from? Right, we're at the REPL. We didn't catch this variable here, but there's a variable we made. It's a list of none values, because print returns none to you, because that's the default return value for a function. What should I have used here instead of a comprehension? A for loop. Any kind of loop. We want to loop over something here. We're not building up a new list. You will see people write code like this. This is not the greatest code, because it's building up a list and then throwing it away. Why are we building up a list of none values and throwing it away? So this is an abuse of comprehensions. This is a time you don't want to use comprehensions. If you're not building up a new list, that's not the thing you care about, don't use comprehensions. So I can definitely say if the side effect is the sole thing you care about, don't use a comprehension. If you want both a side effect and building up a new list, maybe use a comprehension like that pop. All right, an example of when we might not use a comprehension. We've got a for loop here. We are taking data that is in it's a list of tuples. We're opening a CSV file in write mode. We're making a writer object of this file. We're looping over this. We could, the same way here, say, we're going to do this write row for this. Why should I not use a comprehension here? Why is this not so great? Or is this fine? So what this is doing, that's a great question. What is this doing? We don't even know what CSV is. We haven't seen that yet. So I'm kind of assuming a lot of Python knowledge here. We're opening up a file. We are using the CSV module, looping over this data thing to unpack these tuples of colors and frequencies. We're repacking them in a tuple there. And we are calling write row, which writes each row out to this CSV file. So we end up with a CSV file. If this code works, which it does, the CSV file looks like this, the frequency and the color. So the thing this code is doing that's not so great is we're making up a list that has none values in it, and then we're throwing it away. So there is possibly an opportunity to use a comprehension here. The opportunity, though, is in building up rows, saying we're going to make rows like this here frequency color for color frequency. We'll flip these. Instead of color frequency, we want frequency color. And then instead of saying writer.write row, does anyone know another method we could use on CSV? Write lines. So I've done a lot of CSV stuff, so I know about the methods on the CSV writer object. Write rows actually exists. So if we have rows, a list, we can actually call write rows, and it does the same thing. It makes that same data.csv file. So there is an opportunity for a comprehension here, but it's not what we originally thought. We have to use a different method, build up a new list, and write those rows. Questions on this? Yep. Right, so here we're doing something different from before. We're building up a whole list. We now have 2 lists in memory. So this is a different algorithm than what we had before in terms of memory consumption. Is there any way to fix that? A generator? So how do we know whether we can turn a list comprehension into a generator expression? If we're only looping over it once, how many times does write rows loop over rows? What's your guess? Probably once. There's really no reason for it to loop over multiple times. Probably doesn't need to know the length, so we could probably use a generator expression there. We can. What else could we do with this? Yep. Right, so when we see a generator expression hanging out on its own and then we use it, generator expressions are meant to be used once. They almost don't deserve to be in a variable often. Unless there's a reason to give it a name. There's not much reason to give this rows a name. Write rows, it makes it very obvious we are passing rows to write rows. And we can remove those redundant parentheses. So you don't have to write your code this way. Using write rows passing in a generator expression, using write row with a loop is just as valid. It depends on the way you want to structure your code. This is just another way to structure your code. It's another tool in your toolbox. All right, so we don't have too much time left here. I do want to mention that generator functions, which look like this, they have a yield. Who has written a generator function before? Wow, surprisingly, more of you than I thought there would be. So if you're doing data processing, generator functions are great. So generator functions, the great thing about them is, like a generator expression, they actually give us a generator back. This does not have a return here. Instead of return, there's yield. So the thing we get when we call this altogether thing is a generator object. Notice we're not returning anything. Our function, simply because we have that yield statement, we don't have control over what this function returns anymore. It returns a generator. The presence of a yield statement in your function makes it into a generator function, which is a little bit odd. We can copy paste this into a generator expression. If we have a function and all it has is for and if in there, and it looks like something that could be a list comprehension if this were an append, we could instead say, if we wanted to, return, and I'm making a generator expression here. What's the first thing I'd stick in this expression? Yeah, the thing I'm yielding, which is kind of like an append. What's the next thing? Which for? The outer one or the inner? The outer, just like in a list comprehension. It's always the outer for there, and then the inner one, so the fors are the same order. So this is a function. This is not a generator function. It's a function that returns a generator, which seems like a subtle difference. And it is a somewhat subtle difference, but it's a function that has a return value. There's no yield in here, but it gives us a generator object, just like we made a generator object before. So there's an equivalence here. Generator functions can sometimes be turned into generator expressions, not always. They're the general version of a generator expression. So if you find generator expressions just aren't quite good enough for you, you can't just model your data as mapping and filtering and then mapping again and filtering again. You need something a little bit more complex. You could maybe use some tools to help you, like any or all or some other iterable consuming functions out there as helpers, Or if you still can't figure it out, you could reach for a generator function. And you can look those up on your own using yield. Yep.
What is the difference, though, between returning the generator fully baked and doing the yield? I mean, adding some deeper thing in that.
It's subtle. So the difference here is we have control over this return value. We can write a function here that returns a generator if, for example, there are iterables given. And maybe if there aren't iterables given, it decides to return a list. We actually have that ability. We can't possibly do that with a generator function because we don't have control over the return value of a generator function. If we just have even one yield statement floating around in our code in this generator function, it's a generator function now. We have no control over that return value. It's always a generator.
And so is it just syntactic sugar, though, for not having to return the function? The presence of the yield?
The presence of the yield is not just syntactic sugar for not having return, because when you don't have return, you get none by default. It's still a function. Having yield is more than syntactic sugar because it takes over your function. You can't even think of it as a function anymore. It's a different animal. It is a generator function. It gives you items as you loop over it, which is not how functions work. Functions, you call them, they give you an item, they're done.
Sorry if this is getting too in the weeds, but is it similar to almost becoming an iterable, like it's a shorthand for implementing an iterable interface?
Sort of. So the question is this a shorthand for making a function that is an iterable? The function isn't an iterable, but it returns an iterable, because when you call a generator function, you get a generator. We can make any other function that returns an iterable. So there's something called itertools. In Python, itertools has count in it. It has drop while. It has take while. There are a lot of tools in itertools. I talked about zipped longest earlier from itertools import. This count thing here, it isn't a generator that gives us back. It's in fact a count object. But like a generator, it is something that when we call it, it gives us an iterable that happens to be an iterator because we can call next on it. It is lazy. It gives us back. Does anyone know what count gives us? What's your guess that this is going to do? So I've made a C equals count. I said next C 0, next C, we got 1, next C was 2. Print x in C, or rather for x and C we're going to print. Yeah, this gives us all the numbers. So we made a generator that contains every number. My system's RAM on this machine is actually infinite. It's a new model of computer. It's pretty cool. It is not infinite. I don't have infinite RAM. Generators don't store memory. We are generating numbers as we go. This is the same as if we wrote a function where we said count, take in something, defaulting it to 0, and then while that thing is less than infinity, so really a while true here, we're going to say n plus equals 1, and then we yield n. This is pretty much the same as itertools.count. So generator functions are very powerful because they allow you to make infinitely long iterables if you'd like, or really just in any way a lazy iterable. But it's difficult to describe what this animal is until you start trying to use it. It's like a generator expression, but it's more powerful. Yep. Yeah, the reason this works, and you'll have to play with this on your own, it yields the first item. Until we ask it for the next one, it doesn't do anything. Then it does this. Then it keeps looping until it gets to a yield. If we never get to a yield again, our computer's going to hang waiting for that next item. If the function returns, what happens? Does anyone know? Yeah, we get a stop iteration exception, actually. So what happens is stop iteration is raised as we're calling next there, and we are at the end of our generator. So you'll have to look up generator functions on your own. I wanted you to get exposure to these because they are the general version of a generator expression. They're kind of another level there. I don't have time to talk about scope with list comprehensions, set comprehensions, dictionary comprehensions, generator expressions. Know that in Python 3, they contain their scope. Meaning if you say n for n in something, that n is local to that list comprehension. It doesn't leak. If you're in Python 2, different comprehensions do different things. List comprehensions leak and the other ones don't. And that's the historical reasons for that. There are multiple exercise sections on the website we did not get to. I'd like you to do those on your own. If you have any questions at this point, since we're kind of wrapping up here, I guess I should let you all leave the room and probably answer questions individually as opposed to making you feel like you're captive and standing up here in front of you. So I'm going to turn off the mic and wander around. If you do have questions, feel free to ask me. or the TAs if any of them stick around. See you all during the conference. If you do have questions and see me in the hall or just want to say hey, do feel free to do so. I have, what's the thing? Oh, I'm supposed to mention the survey. I remembered. This is the first year I've given a tutorial and remembered to mention to you that there is a survey. Apparently, if you didn't like this tutorial, you can go here and complain. Or if you liked it, maybe you could give good feedback. That's possible too. surveymonkey.com/r/m97726r. That's a not particularly short URL that pretended to be short. I think that's right. Does anyone want to tell me whether that works? It does. Okay, wonderful. So there's a survey there. You can go fill it out. The last thing, the exercise answers. If you stick your email in there, you'll get an email from me. You will get the answers. I don't think I put my email address on the website. If you put in the exercise answers email, you will have my email as well, because I'll be sending you an email. So see you all in the hallway. Feel free to ask me questions afterward. Thank you.